So we are moving forward with our inverse functions. Now we're going to start talking about the domains and ranges of them. Okay, so that's like the new thing for today. So first, let's state the domain and range of this function. And I'm not going to make you graph it. You're going to just use your imagination. But the domain is who's the troublemaker. So who is your troublemaker in that function? Three. Regular 3. I like that. Positive 3. All right, so we're going to kick out 3. 3 is a problem. We're so used to doing that I think that kind of comes easily. The range is a bit harder. You have to leave out where the horizontal asymptote is. I'm going to just throw out the question and say, where would the horizontal asymptote be? I have a feeling I'm going to have to talk you through, but I just want to see if anyone remembers. It would be 0. Your numerator doesn't have an x at all. That's like x to the nothing. It's like x to the 0. This is x to the 1. If your numerator is smaller than the denominator, it's automatically going to level off at 0. Other way you can think of that is it did not shift up or down, so it's still at 0. There's not an up or down shift. Is the other way you can think of that. But good. That's why I throw the question out to see if anybody remembers. That's cool. So that's your domain and range. Now we're going to do exactly like you did last time and find the inverse. So scribble out f of x, call it y. You're going to switch x and y. Everything else stays put. So it'll be x equals 2 over y minus 3. And then you've got to do the algebra to get the y by itself. So what would you do to both sides? No. You're going to multiply by y minus 3. So basically, that's just going to move to the other side. The step that you said is going to happen eventually, though, so just hold on. And I'm sorry, go ahead. So it's up to you. I would not distribute. I think that makes it more complicated, but it's not wrong. So personal preference. I think it makes it more complicated. How else could you move the x to the other side? Yeah, divide by x. So you would get my y minus 3. Geez, can't talk today. Equals 2 over x. And go ahead and say that thing you said before. Good. Then your last step would be to add 3. And I will not take off if you write y equals, but I will be happier in my heart if you write inverse, because that's the notation of what that means. So that's your inverse. Now, please listen to what I'm about to say, because this is very simple and you're going to be upset if you mess it up on the test. We did the domain and range of the original function. When you do the domain and range of the inverse function, you simply reverse them. The domain of the original is going to be the range of the inverse. Because by definition, you literally switched the input and the output, like we swapped x and y. And then the range of the original function is going to be the domain of the inverse. If you're like, that's it, yep, that's it, you just reverse them. And we're going to try that again for number 2. So we're just going to, if you were like, hey, didn't quite get it, we're going to do another one. So we're just going to practice it again. Or question, did I lose anybody there? Or are we all still on board? Okay, well, we're going to do another one. All right, so let's do our domain and range for the original function. Who's your troublemaker that you're going to have to... Good. Kick out -5. And what I tell everybody when you go to do the test, because you know how I leave blanks for you to write everything on? Go ahead and answer the range for the inverse right away. That's the answer. Do you know what I'm saying? Like right now, I don't have a blank up there for you, but like you could fill that part in. And again, what's your range going to be? Yeah, you got it. Everything except 0. So oftentimes it's 0. Unless it shifts up or down, it's going to be 0. And then we're going to find the inverse. So scribble out f of x, call it y. You're going to switch x and y. Everything else stays put. So I did look at the work that you guys turned in, believe it or not. I mean, I glanced at it. You guys know what you're doing. You're good at those steps. The algebra is there. Okay. And then the same thing is going to happen with this one. You're going to multiply over the y plus 5. It's basically going to look like you just moved that to the other side, and you kind of did. That's really all you did there. All right, and then what would we do next? Divide by x. And then your last step is minus the 5. Good. And if you could please write F inverse. Don't say F -1. It's F inverse is how you say that. Although I'm not going to yank you in the hallway and make you take a verbal exam like in your language class or whatever. F inverse of x. And then when you go to do the domain and range of the inverse, you just reverse these two. That's not too bad, right? Just swap them. What's wrong? You okay? Yeah. Okay. Well, I know I didn't say anything fun, so I like it. I like when we got some personality. All right, so that's the first idea that we're looking at today, is you just swap the domain and the range. And then there's one other thing that we're going to look at. So we're going to find the inverse of this and then graph it. Do you remember what I told you to do last time? Should you do the problem first or should you do the graph first? Do the graph first. I'm going to color code mine. You can or not, it doesn't matter. It won't really show up on here anyway. I just do it so when I take the picture, it'll show up. I'm going to make the original one pink and then the inverse green, same as I did last time. Now, using your imagination, before I even put this on here, what will this look like? Well, the domain will be all reals and it will be a U-shaped parabola, okay? You're correct, and we're gonna do that, so just hold on, okay? It moved up 1 unit, so I'm gonna start at 0, 1. And then I would like a few more points, so I'm gonna make a little table. This isn't required, it's just if it benefits you to make a table, then write it. If you're like, no, I can do it in my head, that's fine. Doesn't matter. Give me another number to plug in. 1. So let's plug in 1. 1 squared. 1. Double that. 2 plus 1, 3. So you get 1, 3. And then you can also get -1, 3, because we know it's going to be a parabola. So y equals mx plus b is only for a line. This is a quadratic, so that doesn't apply, unfortunately, but it's kind of like a slope. So I'm going to switch to the other color. And we're just going to reverse those points. So instead of 0, 1, you'll have 1, 0. Instead of 1, 3, you'll have 3, 1. And then also 3, -1. And it's optional, so you don't have to. But if you want to dot in y equals x, so you can see the reflection, you can do that. Kind of helps to check. Now, you should be having thoughts about that. You should be like, wait, hold on a second. But hold on a second, because we're going to talk about that. But just hold on, because I want to go back and do the problem first. But something should be bothering you. You should be like, wait, hold on. So we're going to go ahead and find the inverse. Scribble out f of x, call it y. You're going to swap x and y. So it'll be x equals 2y squared plus 1. And then what? We have 3 steps of algebra. This should be like, can I say this should be the easy part, like the solving part? All right, -1. And then we're going to divide by 2, and then we'll square root. So divide by 2. Now, when you put a square root, what else do you have to put? Yeah, plus and minus. So it is going to be plus and minus square root of all that stuff. And I actually am going to put y instead of f inverse. Here's the reason, and this is what we're going to talk about. What do you notice about the inverse? That's the one I did green. If you can sort of tell, it's this one. What is wrong with that? It's not a function. Why not? The vertical line test. And what happens over here is it's because of the plus minus. The plus minus is what causes that. So the reason I didn't write F inverse is because it's not a function. So technically you can't say F inverse. All right, so that's why I wrote Y. This is going to happen anytime you have an even power. So do you see how that was squared? If you have to the 4th or the 6th or the 8th, if you look back at the notes from last time, I only gave you odd numbers. And that was wise because I saved the even numbers for today because it's a whole conversation. So since it's not a function, you can only do half of the graph at a time. You have to split it in half. Do you remember axis of symmetry from back when we did? Okay, you split it right down the center. So when we're looking at this one, do you see how the original function is split right there at 0? Do you see where I'm pointing? So let's do the first option. The first option would be the positive half. I'm going to do the positive one first. That would be from 0 to infinity with a bracket on the 0. And what would be the range of that? So your domain was 0 to infinity. Good. And the range would be 1 to infinity. Do you see that there? 1 and upwards. So we split it. We only did half. It wasn't all reals anymore. And then when you write down your domain and range for the inverse, watch me point to this. You'll be so upset if you miss it. All you're going to do is take those and do what with them? Just switch them. And on the test, if these are wrong, but you just switch whatever it is that you wrote, I will give you credit for these ones. Okay. And when you do your inverse, you would just do the positive version. You don't put a plus out front. I mean, I guess you can, just don't put a negative. So what you end up having to do is make a decision, which I get is hard. Decision making can be hard. Do I want the positive half or do I want the negative half? Well, here's what the negative half would look like. Again, watch me point to this. If we only want this half of the parabola, what would that domain be now? This is a little tougher to write the negative half. Oh, sorry. Yeah, good. Negative infinity up to 0 would be your domain. Again, you're only doing half of it at a time. You guys need to focus. Right? Negative infinity to 0. Your range would still be 1 to infinity. Are you guys seeing it that there? How I'm pointing at it? 1 to infinity. And then to get your domain and range for the inverse, again, you just swap them. Like literally just copy it the other way around. And again, if you miss the domain, make something up if you can't figure it out and then swap them. I can give you the point for the other answer. And then what do you think we're going to put over here? Yeah, just the negative version of it. So you can't put a plus and a minus. It won't be a function. You have to make a decision. Am I going to do the positive half or am I going to do the negative half? So you have to make a decision. Okay. No, you're going to pick one or the other. It doesn't matter. Well, I was going to say this when I went over the study guide, but since you asked, I'll answer it now. I put 2 of these on the test. One of them, I let you choose. Pick the positive one. The other one, I force you to do the negative one with the idea that you'll do one of each. Okay. And so go ahead and flip over. And so what we'll do you see how I put 2 examples on here, 4 and 5? We're going to do one of each. So we'll do one the positive and one the negative. And then I will give you the halfway through break. Okay. But I want to finish the thought of this. All right. And they won't take too long. So this one will do the positive half. Just use your imagination and I'll grab my sticky note. What direction did this graph shift? I'm hearing both. It went right 5. Look, are you seeing this? Right 5. It would look like this. Yes. Okay. Now we need to cut it in half and I want to do the positive half. So what would that domain be? Perfect. 5 to infinity. And what's the range? 0 to infinity. So I said use your imagination, but I'm going to go back on that actually. Do you see how much that helped for me to just draw a quick sketch? Just draw a quick sketch. Okay. You know your transformations. You did them last year and we did them this year. Okay. Now we're just going to do the problem. Scribble out. Oh, actually, what did I say to do first though? Graph. All right. So I'm going to take my pink pen. We're going to go right 5. And then I'm going to make a little table. What's another number I can plug in? We started at 5, so good. 6 and 7 would be good choices. Okay, bless you. So let's plug in 6. 6 minus 5. 1 squared, 1. Good. If you guys stay with me, that'll be nice and easy. 7 minus 5. 2 squared, 4. And look, you only get half of the graph. It's kind of lonely, but you can only do half, or the inverse won't be a function. It won't work. It won't pass your vertical line test. Oops, this was a 4. Now we're going to take those points and reverse them. Do the graph first, because it's easy to do the graph. Instead of 5, 0, we'll have 0, 5. Instead of 6, 1, we'll have 1, 6. And then instead of 7, 4, we'll have 4, 7. Can you say that louder and I'll answer you? Yes, and that's because this point was at 5, 0, so this one's at 0, 5. And again, optional, you don't have to dot this in, but if you dot in that y equals x, you can kind of see the reflection. That one always reminds me of a fishtail. It looks like a fishtail to me or something. Doesn't y'all see that? I don't know. Yeah. That's what I see when I look at that. All right, so scribble out f of x. We're going to call it y. Foreshadowing. There will be a step where we do a square root. Are we going to do the positive square root or the negative square? Positive. And you don't have to put a plus, just don't put a negative. Okay. So switch your x and y. This is like business as usual. It's not any different. Just when you square root, only do the positive one. And actually, that's the first step to get rid of that squared. So you'd have square root of x equals y minus 5. And then there's actually only one other step, plus 5. Just make sure the plus 5 doesn't look like it's underneath the square root. Or you can put it out front like this if you want. And I can call this inverse now because it is a function. We only did half. And then for the domain and range of that, what are we going to do? Switch them. Just take these and reverse them. I do want to do that last one. Well, we're going to like not break halfway through. We're going to be like practically done when I give you your break, but I want to finish the thought of it. Bless you. Now this one, I want to do the negative half. Let me just real quick draw this for you. What direction did this shift? Good. Just watch. We're going to graph it over here in a second, but look, left 4, up 3, it would look like this. And I'm going to split it in half. And this time I want us to do the negative half, just so we practice doing one of each. So what would the domain have to be if I just do this negative half? Just this half. Negative infinity until, well, it's not a 0. Sorry, my hand was covering it up. Negative 4 is where it's split right down the middle. Do you see that? Because it went left 4. All right, so this will be negative infinity to negative 4. And then what's that range? From where to where? 3 to infinity. Good. Perfect. That went well. So you're going to go left 4, up 3. And now we want some other points to plug in, but you have to pick points on this side. Oh my gosh, you guys are so bro. That makes my life so easy when you're like paying attention. You get that. Like the center is at negative 4. So we're going to go negative 5 and negative 6. I guess, and I'm thinking of this, you could plug in numbers on the other side and then like just reflect them over. Do you get what I'm saying? I don't know. I wouldn't do that. I would just plug in the numbers you want to plug in. Negative 5 plus 4. Negative 1 squared is 1 plus 3 is 4. So you get negative 5, 4. And then negative 6 plus 4. Negative 2 squared is 4 plus 3, 7. So you get negative 6, 7. And again, you only get half of the graph, so it looks kind of lonely. I feel like once you get that, the hard part is done, because the rest of this, like, we have a little bit more work to do, but the rest of it just kind of flows from there. You're just going to take these points and reverse them. So instead of -4, 3, what are you going to have? Yeah, 3, -4, just swap it. And then just swap the points in your table. You'll have 4, -5, and 7, -6. And again, optional, but if you want to dot in that y equals x to see the reflection, I feel like this one's pretty obvious. This one reminds me of like angel wings for some reason. Like, I feel like that's what that one looks like. Letting you into my internal monologue. But if it looks like something's missing, if you're like, hey, it looks like something, it's because it is. We only did half of the graph. You cut off the other half. Is it okay? That's okay. It doesn't need to be perfect. All right, so scribble out f of x, call it y. Now, foreshadowing. We are going to do a square root at some step. What are we going to do? Then, well, it won't be plus and minus. We have to pick one. Just the -1, okay? So switch x and y. It'll be x equals y plus 4 squared plus 3. We're going to have 3 steps of work there. So -3. And then square root, and make sure you put the negative out front. So it's not a plus and a minus, it's one or the other. You're making a decision. You're only doing half of it. And then your last step is, -4. And just make sure it doesn't end up underneath the square root. And you can put it out front, like I wrote that one, up to you. And then I won't take off if you write y, but please try to write inverse, because that's, it's pre-calculus and you guys know the notation. And then your domain and range for that one, again, you're just going to take these answers and swap them. All right, so the last thing that we're going to look at is what a one-to-one function is called. So a one-to-one function means that your inverse is a function. Your inverse will be a function. You won't have to cut the graph in half like we were just doing. So all these ones where you could only do half at a time and you had to worry about, do I want the positive half or do I want the negative half? If your function is what's called one-to-one, you don't have to worry about any of that. It's just good. You need to have that put away. Thank you. Do you get what I'm saying? It's just good if it's one-to-one. So how do you check if it's one-to-one? Because what you're going to be asked is the function one-to-one? There's 2 ways. If you have a graph, it's going to pass the horizontal line test, which is the exact same thing as the vertical line test, except with a horizontal line. If the horizontal line hits it more than once, it's not one-to-one. So you just visually look at it. If the horizontal line hits more than once, then it fails. If you don't have a graph, or getting a graph would be exceedingly difficult, you can work it out algebraically. F of A equals F of B implies that A equals B. And I realize that doesn't make any sense to you right now, but I have a couple on here we'll look at. I'll show you what that means. It's not hard. So for 6 through 11, I don't want to actually graph those. I want us to just use our imagination. We're going to do the parent function. When I say parent function, what does that mean? Perfect. That's what I was looking for. No transformations. Nothing's been done to it. It's still centered at 0. Okay. So imagine your absolute value graph centered at 0. It would look like this. With me? If you draw a horizontal line through it, is it going to hit more than once? Yes. So it is not one-to-one. It fails. Linear, just a plain old line. If you draw a horizontal line through, is it going to hit more than once? No. All right, so that is one-to-one. It passes. Rational, again, not a weird one. Nothing's been done to it. It's the one that looks like this. You know what I'm saying? You draw a horizontal line through. Is it going to hit more than once? No, so it's good. It passes. How about cubic, the wiggly thing? That will be 1 to 1. You draw a horizontal line through, it'll only hit one time. Quadratic is the U shape, the parabola. Yeah, and those are the ones that we were just doing above, they fail. You draw a horizontal line through, it's going to hit more than once. That's why you have to do half at a time. Square root is the one that's like this. Or I guess you guys are facing this way, like that. Yeah. If you draw a horizontal line through, it's only going to hit once. Good, so that passes. So you just kind of imagine what it looks like and think if it would hit more than once. Number 12, I just drew for you. This is a polynomial. If you draw a horizontal line through, do you see how it's hitting more than once? Yep, so that fails. It is not 1 to 1. Bummer. Now, these ones we're not going to graph. I'm going to show you how to work it out by hand. What you're going to, and this is like so silly, but it just trust the process on this. What you're going to do is plug in A for X. If you plug in A for X, it's going to be literally the exact same thing, but with an A instead of an X. Do you see what I did there? Hey, Miss Cole, it looks like you just recopied the problem, basically. Yep. All right. Equals, and then if you plug in B for X, it's going to be the exact same thing, except with a B. Again, just trust the process here. And then what you're going to do is see what cancels. And the order in which it cancels is important. What thing would cancel first for those? The 5s, good. So you would have 3A plus 4 equals 3B plus 4. The order is what's important. The most common thing I write all over these tests, so much so that I wish I had a stamp that said it. Steps are out of order. Steps are out of order. Like that's the most common thing. So that's what we got to practice. All right, what cancels next? The 3s or the 4s? The 4s are what cancel next. So you get 3A equals 3B. And then the 3s cancel. You get A equals B. Oh my gosh, we got A equals B. It passes. Now, if you're thinking, well, wouldn't that just happen every single time? That was your first thought, right? Like, how would that not work? Well, I'm going to show you. Let's try it again. If you plug in A for this, what do you get? Yeah, 1 over A squared equals, and then if you plug in B, 1 over B squared. Now for that, I would cross multiply. Remember this? What would that give you if you cross multiply? Yeah, you would get A squared equals B squared, or B squared equals A squared if you're like, no, I want to write it the other way around. And then what would you do? Okay, when you put a square root, you have to put, so you get plus and minus A equals plus and minus B. Why does that not mean the exact same thing as A equals B? Yeah, good. You could have negative A, positive B, or negative B, positive A, you know, so that fails. And listen, because if you don't actually want to write that all out, I probably shouldn't record this, but I'm going to anyway. If you didn't want to do all that work and you just wanted to go ahead and write no, that's actually fine with me. Because if you understand this, then you're good. What about this is making it fail? And it's because 2 is a even number. Well, yes, quadratic, you're correct. You're right. But what if it was to the 4th? It would still be a no. How about the 6th? Still a no. What if it was the 7th? So you don't have to actually work it out.